This time we are doing more on conditionals, and I really like this task because it is really easy to make the solution overly complicated. And it is not only important to have a working solution. Of course, that's the most important thing. If we have a code that doesn't accomplish tasks that we wanted it to do, it's useless. But whenever we have a code that's already doing what we wanted to do, it's also important to focus on readability. So what do they want us to do in this problem? They are giving us three integers, x, y, and z. So three numbers representing sides of a triangle, x, y, z. And they want us to identify what type of triangle those sides represent. So there are three types of triangle, as they say, and the first type is equilateral, so all the lengths are the same, let's say 5, 5, and 5. And second type is isosceles, and then you have two sides that are the same, let's say 3, 3, and at the bottom you have 2. And the third type is, how do they call it? Scalene. So all the sides have different lengths. And they want us simply to check what kind of triangle we have. The input are three integers, each on a new line. There are constraints, so there are no negative numbers because probably we can't have negative sides of triangles. And also 0 is not allowed, and the sum of any two sides will be greater than the third. That's the condition for the valid triangle. But I think that in our solution, it doesn't really matter that much, but good that they are saying it. And the output format, they simply want us to display to the standard output what kind of triangle it is, scalene, equilateral, or isosceles. And here we have two examples. In first example, they are giving us the following numbers, 2, 3, and 4. Those are all different sides, so the triangle is scalene. And in the second example, they are giving us 6, 6, and 6. All of the numbers are the same, so the triangle is equilateral. Pretty simple tasks, I would say. It's similar to the one that we've done before, but maybe allows for a little bit more freedom in the solution. So let's start writing our solution. We will first open script and try to build a solution here. We are reading three numbers, so 3 times read x, read y, and read z. And now we, of course, want to use if. If we want to check something, then we need to have this if statement. Then double square brackets, because that's the more modern way of doing things, and that's the way that I prefer. And here we want to check some condition. So we have three options. From which one should we start? I would suggest to start with equilateral because it's the easiest to check. So we only need to check two things. We need to check if x is equal to y, and at the same time we want both conditions to be true. So we are building one condition combined of two smaller conditions. First is x equal to y, and second condition is y equal to z. So if that's the case, we know for sure that all three sides are the same length. We didn't have to check if z is equal to x because if x is already equal to y and y is equal to z, then all three have to have the same length. And now we can print this message equilateral, because we are sure that that's the case. Else, let's first do only two cases, equilateral and scalene. And we are closing our if block with fi. If first condition, else if the condition is not true, we are going here, fi closing, the if block, and we can test already our script. It should be working fine. Whenever I'm writing bigger scripts, I like to stop at some point and see if everything is working correctly till this point. And if I already have some bugs, I can fix them easier than if I would test them with the whole script together. Okay, let's execute the script and use those numbers from examples. So here we should get scalane. That's in fact what we are getting, and 666 for equilateral. Sorry, paste equilateral. Till now it works fine. Let's go to the script. And now we need to put the third condition for isosceles triangle, so two sides have the same length, and we can put it here below. If x is equal to y, that's one possible way. Let's say this one is x, this one is y, and they are the same. Then we have isosceles triangle. But that's not the only combination. We could have, for example, z and y, or x and z. So we have three options to choose from, and that's why we are using or. So either this or this or this. And here we used and because we want to be sure that both of them are true, and here we only care if one of them is true. So x equal z or z equals y. Then what? Then this third type, isosceles, and that's it. Let's see if it works. Let's copy the input. Perfect. Perfect. And let's check for isosceles. So let's say we have 5, 5, and 4. Isosceles. Perfect. Let's copy the solution and paste it on Hackerrank. We can run the code to see if it works for them, and we get the message, congratulations, everything is green. Submit the code, and still, even for the hidden test cases, everything is green. Perfect.